Okay, students, this is the classification of defect in solid. As you have got two types of defect, you will get electronic defect and atomic or point defect. Electronic defect you will get when the defect arises due to electrons inside the crystal, and atomic or point defect arises due to irregularities of the particles or due to disorderness of particles. Then the defect is called atomic or point defect. I mean electronic defect due to electrons and atomic or point defect due to particles. Atomic or point defect again can be classified into two types: stoichiometric crystal defect and non-stoichiometric crystal defect. I mean the defects shown by stoichiometric crystal are called stoichiometric defect, and the defects shown by non-stoichiometric crystal are called non-stoichiometric crystal defect. Already I have explained what is stoichiometric crystal, what are non-stoichiometric crystal. Now stoichiometric crystal defect, there are two types. One is called Scotty defect and one is called Frankel defect. These two are very important. There are two types of stoichiometric crystal defect. One is called Scotty defect and one is called Frankel defect. So now first time I will show you about the Scotty defect. Now this is one of the ideal crystal. Here all the particles are present in their own position. There is no defect inside the crystal. That's why now you consider this is ideal crystal. But as you know, ideal crystal exists only at 0 Kelvin temperature. So above 0 Kelvin, in this type of crystal, what may happen? Some of the ions, suppose this positive ion, I mean this cation, may miss from their own position, and it will leave the crystal and it will completely go out from the crystal. Now when this cation is leaving from the crystal, then the number of cation will be less, number of anion will be more. Then the solid will not maintain the electrical neutrality. To maintain the electrical neutrality, since one cation is leaving from their normal side, so automatically one anion also leave from the crystal and they produce some holes. If two cations are missing from the crystal, automatically two anions will missing from the crystal to maintain the electrical neutrality. This type of defect you may get inside the crystal, and this type of defect are called Scotty defect. Have you got it what I am saying? In some crystal above 0 Kelvin temperature, some of the ions may missing from their crystal, and if cations are missing from the crystal, then to maintain the electrical neutrality, equal number of anion also missing from the crystal and they produce some holes. And due to production of holes, this type of defects are also called vacancy defect. I mean they produce some vacant position. That's why this type of defect is also called vacancy defect. And due to production of hole, since it is cation hole, this cation may jump from this to this position. It will occupy the hole, but here again you will get the vacant position. Again this cation may come from this to this position. Again here you will get hole. Similarly the anion can move from one to another position. Ultimately inside the crystal the ions are moving, and due to this movement of ions the solid become good conductor of electricity. So when the crystal is ideal, when there is no defect, it becomes bad conductor, but after showing defect, due to this movement of ions, it becomes good conductor of electricity. Now what type of crystal can show this type of coordination number? Those solid in which the coordination number is high coordination number, and number 2, ions have almost similar in sizes. I mean the cation size, anion size almost same. This type of crystal show Scotty defect. I mean those solid whose coordination number is high and those solid in which the cations and anions have almost similar in size, that type of crystal generally shows Scotty defect. If you want to know some examples, sodium chloride can show, potassium chloride can show, potassium bromide can show this type of defect, cesium chloride also can show this type of defect, silver bromide also can show this type of defect. So Scotty defect shown by those ionic crystal in which the coordination number is high and the cations and anions have almost similar in sizes. So this is about Scotty defect. Now we'll move for Frankel defect. So here I will show the Frankel defect. In Frankel defect, here also the ions will miss from their normal position, but it will not leave the crystal. Suppose this cation is missing from its position, I mean from its normal position, it produces the hole, and the cation will occupy the void. I mean in the gap the cation will enter. This type of defect is called Frankel defect. Here the ions are completely missed from the crystal, but here just displacement of ion takes place. It will leave from its normal lattice point and it will occupy some voids. This type of defect is called Frankel defect. Normally cations are leaving from their normal position. Why? Because as you know, cations are smaller in size and you know voids are very small. That is why if anions are leaving from the normal side, it may not be fit in the smaller void. That is why always cations are preferred to displace from its normal position. Normally cations are moving from their normal position to occupy the void due to small size of cation. And this type of defect shown by those ionic solid whose coordination number is low. And another condition, anions should be larger than cation. These two are the conditions to show Frankel defect. Those solid whose coordination number is very low and those solid in which anions are much larger than the cation, then that type of solid will show Frankel defect. Example, if you want to know silver chloride, silver bromide, silver iodide, zinc sulfide, this type of solid shows Frankel defect. So these two are called stoichiometric crystal defect. One is called Scotty defect and one is called Frankel defect. In Scotty defect, some ions are leaving from their normal position, I mean from their crystal, and if cations are leaving, then equal number of anions also leaving from the crystal and they produce some holes, and that's why this type of defect is also called vacancy defect. And due to production of holes, the ions can move inside the crystal, and due to this movement of ions, it becomes good conductor of electricity. Similarly, in Frankel defect, some ions are missing from their normal lattice side and it will occupy the voids, and due to production of void, it also produces some hole, and due to this production of hole, here also the ions can move from one position to another position, and due to movement of ions, it also become good conductor of electricity. And Scotty defect shown by those ionic solid whose coordination number is high and the cations and anions should have almost similar in sizes. Frankel defect shown by those ionic solid whose coordination numbers are low and those solid in which anions are much larger than the cations, then this type of defect you will get for the solid. So these are the stoichiometric crystal defect which are called Scotty defect and Frankel defect. Now if you want to find out the point of differences between Scotty and Frankel defect, which is very important for exam, write some point of differences between Scotty defect and Frankel defect. How you will write? In Scotty defect, equal numbers of cations and anions are missing from the lattice. In Frankel defect, some ions are missing from their normal lattice sites and it will occupy the void. Secondly, Scotty defect shown by those ionic solid whose coordination number is high. Frankel defect shown by those ionic solid whose coordination number is low. Scotty defect shown by those ionic solid in which cations and anions have almost similar in sizes. Frankel defect shown by those ionic solid in which anions are much larger than the cations. Another point of difference, in Scotty defect, some particles are missing from the lattice. When particles are missing from the lattice, I mean the mass of the crystal going on decreasing, because particles are missing, so mass of the crystal going on decreasing. Since mass going on decreasing, the density of the crystal also going on decreasing. I mean due to Scotty defect, density of the crystal going on decreasing. But in Frankel defect, since the ions are inside the crystal, just is displaced the position from its normal position and it will occupy the void. I mean, number of particles inside the crystal remains same. I mean, the mass of the crystal remains same. That's why density also remain same. So in the solid which shows Scotty defect, it decreases the density of the crystal, but the solid which shows Frankel defect, the density remain same. These are the main point of differences between Scotty defect and Frankel defect, and which is very important for exam. Write some point of differences between Scotty defect and Frankel defect. So this is about the stoichiometric crystal defect. Stoichiometric crystal defect can be classified into two types, Scotty defect and Frankel defect. This is your Scotty defect and this is your Frankel defect. In next we will study about the non-stoichiometric crystal defect.